So in that one, first one, 1,2 diols. So 1,2 diols are also called as ethylene glycol and 1,2 dihydroxy ethane. Now this is the molecule. Now we have to write the structure of the, conformations of the compound. So first we have to write the structure in the form of Sahars. Next. So first carbon have OH and the second carbon have OH, and here is the two hydrogens and here is the two hydrogens. So this is conformation. Now we have to write this conformation in the Newman projection. So first structure, the first carbon OH, highly oxidizing agent, so that should be at the top of the molecule, and here is a hydrogen identified atoms, two are same. And about the back carbon, so this is the back carbon. Now here also we have OH. This OH, the OH eclipsed with each other, and these are the oxidizing agent, and they should be at the top of the molecule. And here is the hydrogen and another hydrogen. So this is eclipsed form of 1,2 diol. Now here this OH and OH eclipse strain, more strain, so more strain, and here another structure to avoid the strain, we are rotating the structure. First carbon substituents are writing as usually, and here is the 60 degrees rotation. So when the OH is there, so it is about 30 degrees rotation. Those are eclipsed with each other. When this OH of the backside carbon, when we rotate about to 60 degrees, these hydrogen and this hydrogen have intramolecular hydrogen bonds. Molecular hydrogen bonding or attraction. Now hydrogen comes here, and this is the hydrogen. This one is called Gaussian structure, eclipsed form and Gaussian form. Next, please all of you mute yourself. Next, Gaussian structure to partially eclipsed structure. OH and hydrogen. Here is the hydrogen. Now, this structure, hydrogen comes here. OH comes here. Please mute your Swati, mute yourself. OH comes here. This OH comes here. That is 120 degrees rotation. So here is a theta is equal to 60 degrees rotation. This is theta is equal to 120 degrees rotation. This is theta is equal to about 0 to 30 degrees. Now the next one. Here is the hydrogen and here is the hydrogen. This is partially eclipsed. Partially eclipsed. So yesterday we have given the names anti and synclinal. Now this is anticlinal plus anticlinal. That is after the 90 degrees rotation. Now there is a first carbon substituents as usually. So this OH comes here, anti to each other, and here is the hydrogen, here is the hydrogen. So this is anti-structure. Now if you observe this four, so from these four, now about the rotation we get the minus anticlinal, then after minus synclinal, then after syn periplanar. So we get 7 structures. Yesterday we have discussed. We get 7 structure: eclipsed, clinal, partially eclipsed, anti, then after anti to anticlinal, synclinal, next planar. So among the 7 structure up to we have to write four structures only, that is anti-structure, eclipsed form, Gaussian form, partially eclipsed and anti-structure. So among these four structure we have to write the stability. So this is first structure, second structure and the third structure, fourth structure. Now priority, now we have to write the stability order. So we have to write the stability order in the conformations of substituted ethane. Now this is the anti-structure. Anti-structure have more stability than the, so this is greater than Gaussian form. Anti is greater than the Gaussian form and here partially eclipsed. Second is greater than the third one and the least one is first one. This is more eclipsed, more strain is there. Now here is the third one. Here also OH and hydrogen eclipsed with each other. So it has the less strain than the first one. Now here is the second one. Here oxygen, hydroxide and hydroxide are the intramolecular hydrogen bonds which is having the Gaussian separation. So this Gaussian separation have less strain than the partially eclipsed. About the anti, here OH and OH are anti to each other. So this one is the more stable. So more stable, less stable. It is in the only saturated conformations and not unsaturated conformation, only saturated. There is no double bond in the molecule takes place. So this is about the 1, 2 diol. And the second one, dihalobutane. Dihalobutane means here the substitution of two halogen groups takes place. Same stability order and the same conformations. So here is the chlorine or bromine, whatever the halogen it is, bromine or iodine or fluorine. So except fluorine. Why? Because this is highly negative. So except fluorine, these three halogen groups which perform the conformations up to this. Now conformation structure. So we have to write this structure in the conformation form, whereas chlorine is more mass containing atom. That's why it is at the top position, and this chlorine referred as referring group. Now here is the backside carbon and hydrogen. Here is the hydrogen. So this is eclipsed form, and this eclipsed form has more strain, so less stable. This is less stable. Next, this structure, another about the 60-degree rotation. Chlorine and chlorine, they are bulky in structure and they have the repulsions. So these are the having the repulsions. Now it is about the 60 degrees rotation. The remaining atom represent as usual. Next structure, partially eclipsed structure. Same structures, but the atoms are different. Hydrogen. So this is partially eclipsed structure, and it is about the 120 degrees rotation, and here it is also less stable. Next, anti-structure. Anti-structure, the halogen groups are anti to each other, and it is the more stable structure. It is about the 180 degrees rotation. It is about the 180 degrees rotation, and here this is more stable. Now we have to write the stability order of the halomethane. Now it is first one. For fourth one is having more than the 60 degrees rotation. Here is the second one, and here third one, and fourth one is first one. So this is the stability order. More stable than the Gaussian, anti-stable than the Gaussian stable than the partially eclipsed, stable than the more eclipsed. So this is the formation of stability order in the 1,2 dihaloethane. And the third one, same conformations, 1,2 diaminoethane. In the place of halogens, we are substituting amino group. So that's it. That is CH2, CH2, NH2. This is amino. 1,2 diaminoethane. About the conformations, same, it has same structure, and here also two amino groups are eclipsed with each other. So this is eclipsed form, theta is equal to 0. This is less stable because of the more steric crowd, and the structure which gives the rotation about 60 degrees rotation amino group. Here these are Gaussian to each other and they are partially eclipsed. Here is the hydrogen. Then next one, amino group, hydrogens and hydrogen. So this is partially eclipsed, hydrogen and hydrogen. And the fourth structure, so I am writing the every structure, so don't get bored. Please try to understand the concept. This is the hydrogen. So this is anti, about 180 degrees rotation. This is 120 degrees rotation. This is 60 degrees rotation. Now stability order. Fourth one is more stable than the second one, and the third one is more stable than the first one. So this is about the stability order. And the fourth molecule, amino alcohols. Amino alcohols means here we have taken two amino groups, but in the amino alcohols we are taking one of the amino group substituted with the alcohol, and here is the another molecule have, another CH2 have NH2 as usual. Now to this one, so first when we take this one as the first carbon, now here is the amine group in the top position, and about the next carbon, here is the hydrogen, here is the hydrogen. So this is eclipsed form. And about the next rotation, same OH comes here, which is Gaussian to amine group, hydrogen and hydrogen. So these are the Gaussian to each other. Here two hydrogens are there. There is no strain. Only here we have the strain because of the amino group and OH group. And about the another rotation, we get partially eclipsed structure, and here is a hydrogen. 1, 2 hydrogen, and then the last structure, amino group, hydrogen and hydrogen. Here is the OH and amino group are opposite to each other. Here is the hydrogens. They are Gaussian to each other. Amino group, bulkier group. Hydrogen is less bulkier. Only single electron containing hydrogen. No steric. So anti-position. So this is eclipsed position. Stability order. Fourth one is greater than, second one is greater than, third one is greater than first one. Same stability order, only the substituent are different. And here is the last example, Halohydrins. Halohydrins. Halohydrins means halogens, and in the previous example we have aminoglycol or amino alcohol. Now in the place of amino group we are substituting halo group, so that is halohydrin. CH2X, whatever the X, chlorine, bromine and iodine. So this is the molecule. X place replaced with chlorine or bromine or iodine, any halogen atom. Now we have to write the conformations, same in the process of before examples. Now here is the OH and hydrogens. So back carbon have halogen, and here is the hydrogen X and H. X H confuse avutara, no problem. So OH, the hydrogen X or chlorine, bromine or iodine. Here also chlorine and bromine and iodine. Now it has the intramolecular attractions between the first compound of OH and the first carbon of OH and second carbon of halogen. Now here is the OH and here is the hydrogens. Here is the halogen atom and here is the hydrogen. And the last structure is OH and X, hydrogen and hydrogen and hydrogen. So this is 180 degrees, 120 degrees, 60 degrees, 0 degrees. Now the stability order. Fourth structure, anti-structure is greater than Gaussian structure. Gaussian structure is greater than partially eclipsed structure. Partially eclipsed structure is greater than highly eclipsed structure. So these are the possibility conformations in the ethane. Next, so these are the saturated. So there is no double bond. Now we are going to write the stability order to the unsaturated conformations, unsaturated compound or unsaturated molecule conformations. Means keto group. Now here butanone 2, 3, 4. So butanone. So these butanone have the conformations. Now I'll write the conformations. So first, so here we have 4 carbons. So in this one we are taking 2 carbons to the first carbon and 2 carbons to the back carbon. Now this is keto group. So carbon. This carbon have attached with methyl group. And now about the back carbon. CH3 eclipsed. Why? Because if you write in a Sahar's manner, keto group and CH3 eclipsed with each other, and here we have the hydrogens. So these are the eclipsed form, that is 0. And the structure, when we rotate about 60 degrees rotation, now CH3 comes here. So first carbon we are writing as usually. So this is the 60, CH3. Now 60 degrees, here is the hydrogen comes here and another hydrogen comes here. So this is 60 degrees rotation. Now another 90 degrees. Same keto group CH3. First carbon atoms and the back carbon about 90 degrees means methyl group comes here. Methyl group or CH3. Same, right? Now H2 hydrogens are here. Next, this is about 90 degrees rotation. Now here another rotation will take place in the CH3 and the back carbon. Now methyl group comes here, partially eclipsed